Welcome students. Here we are going to see another variety of practicals, that is practicals of preparation of derivatives. For your study, these are the derivatives. The first one is P.P.Sutar derivative of phenol. You are going to prepare the derivative of alpha naphthol and P.P.Sutar derivative of neutral, that is hydrocarbon naphthalene. Second derivative is oxalate derivative of neutral, the compound is urea. The third one is nitrate derivative of neutral, the compound is again urea. Then fourth derivative is 2,4-dinitrophenylhydrazone derivative of carbonyl compounds, and these compounds are acetophenone is a ketone and acetaldehyde is a aldehyde. Then oxime derivatives of carbonyl compounds. Sixth one is oxazone derivative of neutral, that is carbohydrates. The compound glucose is taken, and last is iodoform derivative, that is of neutral, the compound is acid. Out of these we are going to prepare 5 derivatives. Okay. Now the definition of derivative. What is a derivative? A derivative is a compound that can be imagined to arise or actually be synthesized from a parent compound by the replacement of one atom with another atom or group of atoms, and these derivatives do not change the original properties of the compound. Okay. Now these derivatives are used extensively in organic chemistry to assist in identifying compounds, and therefore derivatives are important. From this derivative we can have the knowledge of original compound. The first derivative is preparation of P.P.Sutar derivative of phenol. The compound is beta-naphthol, and second is a neutral compound, that is a naphthalene. We are going to prepare P.P.Sutar derivative of these two compounds. The procedure, let us see the procedure. The procedure here is prepare a saturated solution of phenol or neutral compound in benzene. What is a saturated solution? That is a solution in which solid does not dissolve. That is where when going to prepare a solution. For example, we have taken the benzene in test tube and we are adding phenolic compound, and then when first it dissolves and after some time the compound remains insoluble, that is the solution becomes saturated, and such saturated solution you have to prepare of the phenolic compound and also of the neutral compound, where you are going to prepare the derivative of neutral compound. And thus we have prepared the saturated solution of phenol in one test tube and the saturated solution of neutral in another test tube. Now I have taken the test tube of saturated solution of phenol, and to the test tube add solution of picric acid in benzene. Picric acid is a solid and the solution is prepared in benzene, and this also saturated solution. Now in case of phenol, you have to warm the solution of phenol in water bath before mixing with the picric acid in benzene. Okay. Now the third step is shake well, that is after pouring picric acid into the saturated solution of compound, shake well the test tube and pour the contents on dry watch glass. Okay. And as the contents are poured on watch glass, evaporate solvent and get the product. You will get the product on the watch glass. dry the product and find out its melting point. Okay. Here the first one is, this is a beta naphthol. This is the solid beta naphthol. We have prepared the saturated solution of beta naphthol in benzene in one test tube, and we have added, this is a picric acid, the solution of picric acid in benzene. We have mixed this picric acid solution with the saturated solution of phenol in benzene, and after shaking well, we have poured the contents on wash glass. The picrate separates out. Okay. The second picrate derivative is of naphthalene. This is the naphthalene, and these are the naphthalene balls. They are powdered, and the saturated solution of these naphthalene is prepared in benzene, and after that, this is picric acid. The picric acid in benzene solution is poured into the saturated solution of the naphthalene in test tube, and after mixing well, the contents are poured on wash glass. The picrate separates out. Okay, this is the solution. This is a picric acid we have using test tube, and mix the solution and pour the contents on dry wash glass. Okay, after pouring the contents on dry wash glass, the picrates are formed. The first one is the picrate of beta naphthol. This is the picrate of beta naphthol, while this is the picrate of naphthalene compound. Now dry, evaporate the solvent, the picrate will dry, and for melting point, these solids are dried. Instead of in the core, the outer solids are dried. The compound is dried here. Collect the compound from the outer side and find out its melting. Here also, this is the dried. Okay, and collect this and find out its melting point. Thus, the picrate derivative of phenol, that is the beta naphthol, is prepared, and also of the neutral compound naphthalene. The reagent is picric acid in benzene. Picric acid, the structural formula is 2,4,6-trinitrophenol. It is a phenol. Yes, we are going to see the reactions. These are the reaction. This is a phenol, C10H7OH, and this is a picric acid. This is a to the benzene ring 3 nitro groups, and this is OH, that is a phenol, 2,4,6 trinitrophenol. This is a picric acid, and the picrate is formed. This is the beta naphthol picrate, where in case of naphthalene, this is the molecular formula of naphthalene, C10H8, and mixing with picric acid, the picrate of naphthalene is formed. Now the results, find out the melting point of both the picrates. The beta naphthol picrate melts at 462 Kelvin, while the picrate of naphthalene has melting point 423 Kelvin. Thus, we have seen the picrate derivative. We are proceeding for further derivative is oxalate derivative of neutral, that is a compound urea is taken, and the derivative is known as urea oxalate. What is the procedure? The procedure is, the first point, prepare 3 cc saturated solution of urea in water in a test tube. Therefore, take 3 ml water and add urea and prepare saturated solution of urea in water. In another test tube, again take 3 cc of water and prepare the saturated solution of oxalic acid in water. Okay, thus we have prepared two test tubes. In one test tube, saturated solution of urea. In another test tube, saturated solution of oxalic acid. Now, mix together both the solution and shake well. As in previous case, we are going to mix these two test tube in one test tube and cool under running tap water. After cooling, you are getting this type of white precipitate in the test tube. Yes, you are getting the urea oxalate. Filter the PPT obtained, dry and find out melting point after recrystallization from alcohol. That is recrystallize the compound from alcohol. That is add alcohol to the compound and that is it is a soluble and then water you will get the compound regenerated and filter it and find out its melting point. The reactions involved in this oxalate derivative, we have taken the urea compound, we have added the oxalic acid solution, the urea oxalate is obtained. The result melting point of the oxalate derivative of urea, that is a neutral compound, the derivative is known as urea oxalate and it is found to be 449 Kelvin. The second derivative of urea is a nitrate derivative and it is known as a urea nitrate. Again the procedure include preparation of 3 cc saturated solution of urea in water. You have to prepare first saturated solution of urea in water and then add 1 cc of nitric acid to it and shake well. Therefore, you have to add 1 cc of concentrated nitric acid and shake well. After adding the nitric acid, nitration takes place and nitro derivative is obtained, which will be obtained after cooling the test tube. Cool under running tap water, you will get the derivative in the test tube. This is a yellow colored nitrate derivative of urea. Filter the crystals obtained of urea nitrate, dry and find out melting point after recrystallization from alcohol. Therefore, this filter the product, dry it, carry out the recrystallization and then carry out the melting point. The reactions involved, we have taken the urea, we have added nitric acid and this urea nitrate is formed. In the result, note down the melting point of the nitrate derivative of urea, which is found to be 436 Kelvin. Thus, these are the two derivatives of urea. Then, fourth derivative is preparation of 2,4 dinitrophenyl hydrazone derivative of neutral, that is carbonyl compounds are taken here. The first compound is acetophenone and second one is acetaldehyde and we are going to prepare 2,4-DNP derivative of these two compounds. The procedure involves in a dry conical flask, take about 1 cc of the given liquid. Of course, acetophenone is liquid, acetaldehyde liquid. Yes, you have to take 1 cc of liquid in a dry conical flask. The conical flask must be dry. Then add about 5 cc of 2,4-dinitrophenylhydrazine solution which is prepared in the alcohol and therefore add 5 cc of the reagent to the compound and a drop of concentrated sulfuric acid, the dehydrating reagent. Shake vigorously and heat for 5 minutes if necessary. The heating is not required because concentrated acid has sulfuric acid added and therefore product is formed. Okay. Then keep the flask, that is solution, for about 5 minutes. You have to keep the flasks at room temperature. Okay. Aldehyde or ketone reacts with this 2,4-diphenyl hydrazine reagent, and yellow or orange crystalline solid separate out. Okay, we are going to see these products. Then filter the product dry and take melting point, that is recrystallization, from 50% alcohol. That is, you have to use 50% alcohol for recrystallize. Okay, this is, you have taken the compound in the flask, conical flask, and this is a 2,4-DNP reagent. Add 5 ml of the reagent. This reagent is added. Okay, thus this product is obtained. This is the DNP product, orange colored product. Filter this, dry, and find out melting point. The reaction is carbonyl compound reacts with 2,4-dinitrophenylhydrazine and water molecule is removed, rehydration takes place, and phenylhydrazones are obtained. This is a phenylhydrazine, phenylhydrazone is obtained. This is 2,4-dinitrophenylhydrazone. The product may be orange, as we have seen, or yellow. Okay. In case of acetophenone, orange product is obtained. In case of acetaldehyde, yellow product is obtained. We have seen the product. The reactions are acetophenone, that is C6H5COCH3, acetophenone. This is a reagent 2,4-dinitrophenylhydrazine. This is a 2,4-dinitrophenylhydrazine. The product is obtained, that is a 2,4-dinitrophenylhydrazone of acetophenone. Water molecule is removed. With acetaldehyde, this is a acetaldehyde, CH3CHO. Reagent again 2,4-dinitrophenylhydrazine, and hydrazone is obtained. This is a 2,4-dinitrophenylhydrazone of acetaldehyde. Okay. What are the results? The results are, the first one is melting point of the DNP derivative of acetophenone, which comes about to be 511 Kelvin. And the second one is melting point of the 2,4-DNP derivative of acetaldehyde, which comes to be 435 Kelvin temperature. Thus, there are two hydrazone derivative. The compounds are two. First is acetophenone, second is acetaldehyde. Thus, we have seen the practicals of derivatives. Thank you. Students, write this practical in the journal.